Alright, so this sample problem is related to Kepler's laws of planetary motion. A satellite orbits the Earth in an elliptical path. As it travels from position 1 to 2, which of the following is true regarding the motion of the satellite? Now remember that according to Kepler's laws of motion, the angular momentum as the satellite moves around a planet is going to be constant, or it's going to be conserved, meaning to say that the initial angular momentum is equal to the final angular momentum since there's no external torque. So when we say that angular momentum is conserved, that means to say that it is not going to change. So as far as the angular momentum is concerned, it should remain constant always. So we are actually left with B, C, and D. Now, as we expand the fact that the angular momentum is conserved, or as we expand Li is equal to Lf, we have the formula, the moment of inertia initial multiplied by the angular velocity or speed initial should be equal to the moment of inertia final multiplied by the angular velocity final. And when an object is rotating about an axis that is outside of its body, then the moment of inertia is just gonna be mr squared. So the moment of inertia initial would be mri initial multiplied by the initial angular speed is equal to mrf squared multiplied by the angular speed final. So in order to, now as the object moves from position 1 to position 2, this is our initial and this is our final. So as the object moves from position 1 to position 2, your radius decreased. So meaning to say that your R1 in this case, our initial, is greater than your R final. So in fact, the radius R decreased. So in this case, if we look at this equation, as we decrease the radius, in order to maintain the equality, so therefore your angular speed has to increase. So if your radius decreases, your angular speed has to decrease in order to maintain the balance. So the mass cannot decrease or change because the mass is actually constant. So in fact, we could take it out of the equation. The mass does not change, so we could just take it out of the equation. So if we change the radius, automatically the angular velocity would also change. So if we decrease the radius in order to maintain the balance or maintain the equilibrium, then your angular speed has to increase. And for that case, we are left with C and D. So B is now out of the picture. Any questions before I proceed? All right. So now as we expand this equation, so we have R initial squared. Now remember that omega is actually equal to V over R, or the linear speed divided by the radius. So I'm gonna change my angular speed to and express it in terms of linear speed. So omega initial would be equal to V initial over R initial is equal to R final squared multiplied by omega final would become V final divided by R final. And that allows me to cancel the square on the left and the right side of the equation. So that gives me Ri Vi is equal to Rf Vf. So where V is my linear speed. So now, going back to the situation, your object or our satellite goes from 1 to 2 where the radius is decreased. So as we decrease our radius, what should happen to the linear speed in order to maintain the balance? Anybody?
It will increase.
Very good. If we decrease the radius, our linear speed should actually increase in order to maintain the equilibrium. So in that case, the answer is going to be letter C. So angular momentum is always conserved, and when we decrease the radius, then the angular speed will increase as well as the linear speed. Now, here's the question. What if instead of the satellite traveling from position 1 to position 2, it now moves from position 2 to position 1? What happens to the angular momentum?
It will decrease.
Why will the angular momentum decrease? What did we say about the angular momentum?
The angular momentum will stay constant, but the angular speed will decrease.
All right, very good. The angular momentum is always constant whatever the motion of the object is. So whether it goes from 1 to 2 or 2 to 1, the angular momentum remains the same. What happens to the angular speed?
Decrease.
It will decrease because when we increase the radius, then the angular speed has to decrease. And the linear speed, similarly, as we increase the radius, then the linear speed will decrease. Questions? Alright, so if none, then I need you to proceed with the rest of the task. You have 12 minutes to complete the answer to slide 56. Do not forget to tap on please check and write your solution.